So in today's video we'll be looking at the exponential function. Okay, so we will be looking at the basics of the exponential function, and I hope that you will find value and understand, or rather understand better, of course. Yeah, so the exponential function. Okay, so first of all, the exponential function is given as a raised to the power x, right? It's always raised to the power x, right? Hence why we're saying it's an exponent. It's an exponential function, an exponent, because it's raised to the power x, and hence that's an exponent in that case. So remember when on our prior video we did some simplification and solving of equation dealing with exponents. Well, that will be needed for for exponential functions when you have to calculate the x-intercept and your y-intercept, of course. So now in this case, let's look at the basics of the exponential. Let's further understand the exponential graph first. Okay, so first of all, now we have a as our base. Remember we said a is our base, and then x is our exponent. Now let us look at what happens when a graph of a raised to the power x, when a is greater than 1, right? Let's see what happens with that graph. Let's say, for instance, let's say a is equal to 2, right? And hence we have a we have y is equal to 2 raised to the power x. Let's say we have that. Okay, so now with this one here, what I'm gonna do is I'm gonna place in a box, right, to write all my values and all my x and corresponding y values in that case, right? Okay, let us write a box, and hence I'll have my y and hence I'll have my I will have my y values, and I'll have my x values. Okay, so now you can give me any y value, or rather any x value that one wish. Okay, now let me do this. Okay, so you can give me any x value. So let's say we have 2, right? So when we have x is equal to 2, we're going to take this 2 and plug it in place of x, and hence we have a y value of 4. Now if you have 3, let's start with 0 in that case. Let's start with 0. If we have 0, then we'll have 1, right? Then if you have 1, you'll have a y value of 2. If you have a y value of 3, x value of 2, then you have 4. You have 3, you have 8, right? And then you have 4, you have 16, and so on. Okay, so those are the numbers that you're gonna use. Okay, let us plot the graph. Let us plot this graph here. Okay, so now the question is, what if I plug in a negative x value there? What will happen to my graph? Well, if I plug in, let's say, negative 1,000, then I'll get a y value of 0, let's see, then I'll get, let's say, 1,000, or rather 100. Then you get a very small number, 0,00000000000, so and so on, 7 8888886, right? You'll get a number that is very close to 0. Okay, so meaning my graph comes from this side here, very close to 0, and then it accumulates to the upside, right? It accumulates to the upside, and here we have a isotones, right? So we have a horizontal isotone, right? A horizontal asymptote, which is y is equal to 0. So meaning you'll have this point here as my asymptote, right? So what that means, it means that y, rather our function approaches that value, but it cannot be equal to, or rather our function approaches 0, but it cannot be 0, right? Rather it does not reach that value. So if you plug in like 2 negative 1000 on your calculator, you will get a value of 0, right? You will get a value of 0, right? If you plug in 1 million, you will get a 0. So that means that from going to negative infinity, right, our function approaches as x approaches negative infinity, then our equation, or rather my y tends to be 0, right? So that will deal with that when dealing with calculus. But here you notice that, okay, if I plug in a number like 1000 or million, then I get a y value of 0. Now y cannot be equal to 0. Why? Let us see. If y is equal to 0, well, you don't have an x value, right? That means you don't have an x value, because I can say, well, this is ln 0 is equal to x ln 2, right? Which in that case will give me a math error if I want to solve for x, meaning there is really no y, that y is equal to 0 does not exist in that case, right? And hence that now will be my that will be my asymptote, right? A value that asymptote basically means that a value that a graph approaches but cannot reach, right? You can see that this function here, it goes on and on till negative infinity, but it does not cross over this line here. It will go above the x-axis, but it will never cross below that zone, right? It can never cross below that zone, right? And it makes sense, because if my y is equal to 2x, or rather 2 raised to the power x, sorry about that. So if my y is equal to 2 raised to the power x, and we're saying that if the line crosses up below the zone here, that means that I'll get a negative y value. And in this case, whatever value that I plug in place of x will never give me a negative, right? It can be any value, right? Can be any value, it will never produce a negative, right? So it makes sense, right? It kind of makes sense, or rather it does make sense in that case, that my function will be above the x-axis and will never cross below the x-axis. So that is basically when we are dealing with when our a is greater than 1. When our a is greater than 1, so when our a is greater than 1, you can see, how do I find my y-intercept? Well, my y-intercept, you let x equal to 0, so in that case y is equal to 2 power 0, which is equal to 1. So meaning this point here will be my y-intercept, and hence the graph will continue to infinity, positive infinity and negative infinity. So that is how you sketch a graph that is like that, right? That is how we sketch that graph, right? Okay, so moving on. So now that we know our y-intercept, and then we know when this graph here is greater than 1, then our function increases, right? That's another thing, our function increases. Remember, when they ask whether a function increase or decrease, you look from left to right, right? It comes from the left hand side to the right hand side. You can see from the left it comes and go all the way up, so meaning our function in this case keeps on increasing and increasing, right? And let's look at the range, right? Remember, we did the range on our prior videos, right? So what is the range in this case? Well, when we're looking at the range, when we talk about range, we're talking about y values, right? We're talking about y values. Now Now, what we mean by y values, right? So when we're saying range is a y values, we basically mean that the y values that that are on the graph, or rather the what are the y values that satisfy this graph, if you are getting me, right? So basically mean that which values of y are included in this graph here, right? And then that's what we mean by a range, the values of y that are included in this case. So if I ask you which values of y are included in this case, you can see that all these values are all this side here. What are the niches? Do this. So you can see that by looking at this graph here, all these values here below are excluded, meaning they are not on the graph, and all the values above 0, or rather my y values, remember this is the y side and this is my x, so all the y values here are included on the graph. So that is what we mean by finding the range, all the y values included on the graph. So in this case, the y value, they start from 0, so the y values, they start from 0 moving high, so meaning my range will be y is greater than 0, right? So my y is greater than 0. Okay, so now we did not include the 0 because we just said that my function approaches 0, right? Y at 0, but it does not reach the 0, but it does approach it, so meaning we did not include the 0. And then my x, my domain, right? So my domain are x values, of course. So x values, again, the x values on the graph, so all the x values are on the graph, right? So all the x values are on the graph. Any x value that you put there will produce a value, so meaning there is no value of x that is excluded, meaning, okay, we can say, well, x is the element of real numbers, or you can say, well, x an element of negative infinity to positive infinity, so meaning all the numbers from the left to all the numbers to the right. Okay, I hope that makes sense. I tried by all means to explain this a little bit more simpler. Okay. And another thing is, okay, if you don't know, or rather you want to remember this thing here, what you can do is, if I give you y is equal to 2x to graph this graph here, now on your mind will be, okay, this graph is either like that or like that, right? And then you put in the highest or the lowest x value that you can take. Let's say I put in 1,000, then I would say, well, 2 or 1,000, and then I can notice that, okay, 1,000 is on this side here, right? On the x values is on this side, it's on the right hand side. So when you put 1,000 there, you get a huge number, right? You get a massive number. You can't even put on a calculator. But let's say 10, right? Let's say 10, you'll get this number here, so 1024. So you get 1024. You can see from this graph here, you can see this graph here from 10 is basically at something like 2, right? It's basically a 2, right? So meaning we cannot use, so that means that we cannot use this one here, right? You cannot use that one, and hence we have to use this one that accumulates up, right? I hope that makes sense. Okay, let us move on to another one here. Now let's say my a is greater than 1. I mean, it's greater than 0, but at the same time is less than 1. Of course, a is always greater than 0, but in this case we are looking at the a value that is less than 1, right? Here in this case it was greater than 1. Now we're looking at the a value less than 1. Okay, let's look at an example. Let us say, well, if my y is equal to 1 over 2 raised to the power x, right? Let's look at this, right? Again, you're going to do the same thing. Draw the box, right? I'm going to draw this box here. Then I'll have my y values and then my x values, and then 0, 1, 2, 3, 4, right? Then I have when I have 0 I have 1, when I have 1 I have a half, when I have 2 I have 1 over 4, then okay, let me just, when I have 1 I have a half, when I have 2 I have 1 over 4, when I have 3 I have 1 over 9, or rather 1 over 8, and then when I have 4 I have 1 over 16. Okay, so in this case here we notice something. We notice as my x value increases, my y value decreases. So meaning from this side here, from my x values being large, my whereas my x value, as my x values increases, so meaning from positive infinity coming left, you can see when I go from 4, 3, 2, 1, I increase my y value. Notice that 1 over 16 is less than 1 over 8. A half is greater than 1 over 4, so meaning that my function will be something that looks like that, right? So meaning as I come from the right hand side, or rather as I go to the right hand side, see from 1 going 1, 2, 3, 4, 5, 6, 7, 8, my y value keep on decreasing and also approaching 0, right? Is also approaching 0. And of course as I move from right to left, my y values increase. Then you notice that okay, my y-intercept is 1 because 0 and 1. Okay, so in this case here I have a y-intercept of that. My asymptote remains y equal to 0. Why? Because my function there, it does not break below, or rather touch that line there, so it stays above it. It stays above it, right? So yeah, so if like you put in a value like 7,000, you will get 0. But because you are using a this small calculator, it cannot like give you all the zeros on your calculator, of course. So I mean, if you use a bigger screen, then you will see that you will get something like 0,0000, the endless zeros, and then a number after that, right? Because you're using a calculator, it cannot produce all the zeros. It will just give you, or rather round off your answer to 0, right? I hope that makes sense. So yeah, so basically the difference between these two is basically my this one here is an increasing function because from left to right I'm increasing, and this one here from left to right basically decreasing, so meaning this one will be a decreasing function, right? I hope that you understand this one here. Basically the range and the domain is basically the same as the top part here. Remember, numbers that are included on the graph, right? In this case here my y values are not included, or rather the negative values are not included, meaning that all the positive numbers on the graph are included, and hence that will be my range, right? And hence that will be my range. And then for the x domain, right, all the values of x are included in the graph, right? So this function here goes on and on and on, does not end, and so on with the right hand side, does not end. So meaning my x value can be any number, right? Can be any number, so meaning from negative infinity to positive infinity. Right, I hope that makes sense. And in our next video we'll be looking at the transformation, the transformation of the exponential function, right? Yeah.